In this video lecture, I am going to cover the following these 26 topics on the matrices, and we will start with the input of the matrices in Scilab. How we can input a matrix in Scilab. So let's open the editor. I have written two commands, CLC and clear. CLC will clear the console, and clear command will clear the memory of the Scilab. So let's start with the input of the matrix. So we can input a matrix in two ways. One, directly in the Scilab editor, and the second one through the user. So we will look at the both. So let's first enter the matrix in the editor itself. 1, 2, 3, semicolon, 4, 5, 6, semicolon, 7, 8, 9. So let us display the matrix. The matrix A is this A. So when I execute this code, I will get a matrix A with 3 into 3 size, number of rows 3, number of columns 3. The first row is contains 3 elements 1, 2, 3, and the second row also contains 3 elements 4, 5, 6, and the third row contains elements 7, 8, 9. So if you look at the code in the editor, we can see that each row is separated by a semicolon. So in the first row, the elements are 1, 2, 3. So elements in each row are separated by a space, and then when we want to enter a new row, we will uh, write a semicolon and then start with the second row. So and what we observed is the elements in the first row 1, 2, 3 are separated by a space. Similarly, the elements in the second row are also separated by a space, and the two rows are separated by a semicolon. So in the same way, we will enter another matrix B. So now let us execute the code, and the output in the console is the matrix A is 1, 2, 3, 4, 5, 6, 7, 8, 9, and the matrix B is a identity matrix with the diagonal elements equal to 1. So we have learned how to enter matrix using editor. Now let us come to the next story, how we can enter a matrix using user, through the user. So what we will write, instead of writing this command, we will write here C is equal to input double quotes enter matrix C. Now I will write this double quotes, the matrix C is, and this C. So what it will do is, this will ask to enter the matrix C. Similar in the same way, 1, 4, 5. This is first row. Now semicolon. Now we will enter the second row elements. 2, 5, 1, semicolon, 6, 7, 0. Now when I press the enter, it will display the matrix C. So as you can see, 1, 4, 5 are the first row elements, 5, 1 are the second row elements, and 6, 7, 0 are the third row elements. So we have learned till now how we can enter a matrix using the editor, or how we can enter a matrix through the user. So in this lecture, we are going to use only the matrix entered in the editor itself. So now the next topic is addition of two matrices. So let us make a comment, addition of matrices. So we will store the addition in a third matrix C, and therefore we will write C is equal to A plus B, and this double quotes the addition of matrix A and B is disp C. So this will add the two matrix A and B and store the addition in the third matrix C. So let us execute the code and see the output in the console. So as you can see, 1 plus 1 is 2, 2 plus 0 is 2, and 3 plus 0 is 3. So as you can see, this is the sum of the above two matrices A and B. Similarly, we can perform subtraction and multiplication of the matrices. Let us do that also. So for the subtraction, we will use A minus B and write subtraction here. So we have modified the code to display the subtraction of two matrices A and B. So as we can see, 1 minus 1 is 0, 2 minus 0 is 2, 3 minus 0 is 3, 4 minus 0 is 4, 5 minus 1 is 4. So we can see that the subtraction of matrix A and B is displayed on the console. Now let us come to the multiplication of the two matrices. So multiplication requires that change the multiplication of matrix A and B is, and as we can see in the console, the multiplication of the matrix A and B is displayed here. Now the next topic is element wise multiplication of matrices. So we have performed the multiplication of matrices. Now we will perform the element wise multiplication. So in order to perform the element wise multiplication, the operator will be dot star, and here we will write element wise multiplication of matrix A and B is, and now again I will execute the code, and we can see only diagonal elements are there, because when we multiply perform element wise multiplication of matrix A and B, so 1 will be multiplied with 1, or we can say A11 will be multiplied with B11, A12 will be multiplied with B12, and A13 will be multiplied with AB13, and this and so on. So Aij will be multiplied with Bij only. So we can see that in case of matrix B, all the elements are 0 except diagonal elements. Therefore, in case of element wise multiplication, the resultant matrix obtained or the output matrix obtained will contain only diagonal elements. And we can see 1 into 1 is 1, 5 into 1 is 5, and 9 into 9 is 1 is 9. So we have obtained a diagonal matrix. So till now we have performed the first 5 operations, and or we have covered the first 5 topics up to element wise multiplication of matrices. The next is sum of rows elements of a matrix. So for this we will consider the matrix A and perform the calculate the uh, sum of rows elements. So for example, in case of matrix A, the first row is 1 2 3, the second row is contains elements 4 5 6, and the third row contains 7 8 9. So we will calculate the sum of each row separately. C. Okay, and this double quotes sum of elements of rows, or we can write row wise sum of elements of matrix A are disp S. And now we will execute the code, and we can see 1 2 3 is 6, 4 5 6 is 15, and 7 8 9 is 24. Similarly, to calculate the sum of all elements of matrix A, we simply change the C with R, and here we will write column wise sum of elements of matrix A, and again we will execute the code, and we can see that 1 plus 4 plus 7 is 12, 2 plus 5 plus 8 is 15, and 3 plus 6 plus 9 is 18. So this will give me the column wise sum of elements of matrix A. The next topic is sum of all the elements of a matrix. Now we want to, if we want to calculate the sum of all the elements of the matrix, then we will remove this extra argument, and we will calculate the sum of elements of a matrix and then execute the command. So we can see 45. So all the elements of matrix A, when we add them, we will get 45. So the sum of elements of matrix A is equal to 45. Product of rows elements of a matrix, product of column elements of a matrix, and product of all elements of a matrix. So we will calculate these three products, and this will cover the three topics 9, 10, and 11. So let's do that. Let's move to the editor. We will replace S with P. A with A will remain same. Since we first I want to calculate the column wise product, therefore we will use here R prod. Okay, and column wise product of elements of matrix A, and here we also write P. Now when we execute this command, we will get 28, 80, 162. Since we want to first calculate the column wise product, therefore 4 into 7 is 28, 2 into 5 into 8 is 80, 3 into 6 into 9 is 162. So this is the column wise product. Similarly, we can calculate the row wise product if we use C here, and we will write row wise product, and then if we execute, we will get, as you can see, 2 into 3 is 6, 4 into 5 into 6 is 120, 7 into 8 into 9 is 504. So what we observed is, if we write, if I want to calculate sum, then I will use sum. If I want to calculate the product, I will use prod command, and to calculate the row wise product or sum, I will use a second argument colon C, and to calculate the column wise, I will use colon R. Similarly, if I want to calculate the product of all the elements of a matrix A, then I will remove the extra argument, and then I will execute the code. So we can see this is the product of all the elements of matrix A. So what we have done till now is we have calculated the product of rows elements of matrix, column elements of matrix, and all the elements of matrix. The next is display diagonal elements of a matrix. So what I want to do is, now I want to print only the diagonal elements of the matrix in the console, and for that what we will do is we will use a command diag, diag. So what we will do is we will write d is equal to diag a disp the diagonal elements of matrix A are disp D. So as we can see, the output is 159, and we can see here also the diagonal elements of matrix A are 1, 5, and 9. Now the next topic is size of matrix. So size of matrix means number of rows and number of columns, and for that we will use the command size, and we will use for that S, and here also I will write S. The size of matrix A is, as you can see, the size of matrix A is 3 and 3. So the first 3 will represent the number of rows, and the second 3 represents the number of columns. So 3 rows and 3 columns. Now let's come to the next topic. Print a specific element of the matrix, say Aij. So now I want to display the Aij element on the console. So for that, first we will enter the value of I and j. So I is equal to input double quotes, enter the value of I, j is equal to input double quotes, enter the value of j. Now this double quotes, the Aij is equal to this a bracket start I comma j. So I have written ai comma j. I is the first index and j is the second index, representing the row and column respectively. Now I will execute the code. So the value of a, let us choose I is equal to 2 and j is equal to 3. So a 2 3 will be 6. So as you can see, we are getting the output 6. So in this way, we can extract any element of the matrix by just specifying the ith and jth index corresponding to row and column of the matrix A. So what will be the next topic now? Swap or the 16th one. So this is the current we have done. Now the next is extract ith row of the matrix and display it in console. So now let us go to the, so this time we have to extract the ith row of the matrix A and display it in the console. Now let us make this as comment. So now when we execute the code, it will ask us to enter the value of I and we have to display the ith row. So now let us change this command. The ith row of the matrix A is, since I is fixed, in case of ith row, I is fixed and the value of j can move from 1 to 3. So here, since j can take any value from 1 to 3, so therefore we will replace it with the colon so that j can take all possible values. And since the matrix is of the order of 3 into 3, therefore j will start from 1 and end with 3. So I will use colon. So by default, colon means starting value and ending value it will take accordingly. Now we will execute the code and let's see what we are getting. So they enter the value of I. So suppose I want to print the third row which contains the elements 7, 8 and 9. So I will choose I is equal to 3 and we can see the ith row of the matrix A is 7, 8, 9 and in our case the ith row is the third row. Therefore we are getting 7, 8 and 9. So in this way we can extract any row of the matrix and in the same way we can also extract any column of the matrix. So let us see that also. So now in that case if I want to ith column, so I will write here I and now I will use colon here and I here. Okay, or in other way we can write jth column so that it will make our concept simple. We will use I for the row and j for the column. So what I will do is jth column my, or now I want to extract from the matrix A and display it on the console. So let us execute the code. Now we can see enter the value of j. So now this time I want to print the, or I want to extract the second column from the matrix A which contains the elements 2, 5 and 8. So let us enter the value of j equal to 2 and we can see that the jth column of the matrix A is 2, 5 and 8. So in this way we can extract any column of the matrix and can display it in the console. Now let us come to the another topic. Replace Aij with a random number between 0 and 1. So let us remove this as from the comment because we need the Aij element of the matrix. So Aij element of the matrix A is I comma j. Okay. So this is the A bracket I comma j is the Aij element of the matrix A, and we have to replace it with the random number between 0 and 1. And for the random number we have a command in Scilab which is rand and bracket. So this rand command will randomly choose a random number between 0 and 1. So what the command or the line 13 will do, it will replace the Aij element with the random number between 0 and 1. Now let us display the modified matrix display and this double quotes the modified matrix A is, and we will remove this because we do not need this. Now let us execute the code. So enter the value of I. Suppose I want to change the A to 2. So I will take I is equal to 2 and j is equal to 2, and we can see the old matrix or in the original matrix the A22 is 5, and it has been replaced with the random number between 0 and 1.849. So every time we run the code, this value will be different. So let us again execute the code, and this time again we will enter 2, and we can see earlier the value is different and now this is different because we are choosing the number between 0 and 1 randomly. So every time we execute the code we will get a new number between 0 and 1. Okay, so in this way we can replace any element of the matrix with a specific element. So here I am replacing it with the random number. The next topic is swapping of Aij and Abi. So let us remove this code. Now I want to swap the Aij with Abi. So first I will store the value of Aij in some another variable, and now what I will do is Aij will be is equal to Ji. So what is the reason of storing this Aij in a uh, temporary variable temp? Because when we execute the command ai comma j is equal to aj comma I, the value of ai comma j, the original value of aij will be overwritten with the value of aji, and we are not able to swap the variable. So now I can do this. So since temp contains the value of aij, we are able to overwrite the value of aji with aij. Okay, so this first what we will do is we store the value of aij in the temp. Now I will replace the value of aij with the agi. Now we have to replace the value of aji with the aij, but aij is already overwritten, and for the safer side I have stored the value of aij in temps, therefore I have written temp here. Now we have replace the value of aij with agi and the value of agi with aij, and this is called swapping. So now let us display the modified matrix. So we can see the original matrix is 1 2 3 4 5 7 8 9. Now if I want to interchange a12 with a21, so a12 is 2 and a21 is 4, so I want to interchange them or swap them. So I will use I is equal to 1 and j is equal to 2, and we can see we have successfully swapped the values of ai and aij and agi. Now what is the next topic? As we can see, determinant of matrix. So this is very simple. In Scilab we have a inbuilt command to calculate the determinant of matrix, and for that let us use det. So det will calculate the determinant of matrix A and it will be stored in the variable d. Now let us display the determinant of matrix A, this D. So we can see the determinant of matrix A is minus 9.516 D to the power minus 16. So which is approximately equal to 0. D minus 16 means 10 to the power minus 16. So this is approximately equal to 0. And therefore, if we calculate the inverse of this matrix, we may get some error. So let us try to calculate the inverse of the matrix. I is equal to inva. This will calculate the inverse of matrix. This double quotes inverse of matrix A is this I. So let us see what we get. So we can see inverse of matrix is too high because the determinant is very low. So since the determinant is not exactly equal to 0, but some 10, but is of the order of 10 to the power minus 16. Therefore, we are able to calculate the matrix. But as you can see, matrix is close to singular or badly scaled. So why we are getting this message? Because our determinant is very close to 0. So if the determinant is finite or not so much close to 0, in that case the matrix inverse of the matrix A will be calculated successfully. So here we can see that we can say that the matrix A is singular. Now let us come to the next, transpose of matrix. So how we can calculate the transpose of matrix A? So let T will be represent the transpose A prime. So A prime will give the transpose of matrix A, and that transpose will be stored in variable T or the matrix T. So this double cos transpose of matrix A is this T. And now let us execute the code, and we can see the matrix A is this and the transpose of matrix A is 147. The rows are becoming column. Okay, so we have successfully calculated and displayed the transpose of matrix A on the console. The next is trace of matrix. So trace is what? Trace is basically the sum of the diagonal elements, or this is also equal to the sum of eigenvalues of the matrix A. So now let us calculate the sum of diagonal elements or the trace of A. So T R is equal to trace bracket A. So trace command will calculate the trace of matrix A. This double quotes the trace of matrix A is this TR, and we can see 15, and if we calculate the sum of diagonal elements, it also comes out to be equal to 15. So the trace command successfully calculates the uh, trace of the matrix or the sum of the diagonal elements of matrix A. So now the next topic is define an identity matrix. So how can we define an identity matrix? So there is a very simple command I, which calculates the or uh, which can be used to define a identity matrix. So let us denote it with the I. Now I want to uh, uh, input a 3 into 3 dimension identity matrix. So I will write 3 comma 3. First 3 will represent m number of rows, and the second 3 will represent n number of columns. And now let us display the identity matrix is disk I. So now let us see what we are getting. We can see that we are getting the identity matrix is 1 1 1. So in the matrix B we have entered in the Scilab manually, and here we have used just a simple command I, and it displays the 3 into 3 identity matrix in the console. The next matrix is define a zero matrix. So how can we define a zero matrix? We simply write here zeros, and let us denote it with Z, and here you also write zeros matrix is, so a zeros matrix of order 3 into 3 will contain 9 elements and all the elements are equal to 0. So as you can see, it contains 9 elements and all the elements are equal to 0. Similarly, we can define a matrix having all elements equal to 1. So for that we will use ones here, and in place of that let us use O, and this is called ones matrix. And now let us execute the code, and we can see all the elements of the ones matrix are equal to 1. So now let us come to the second last topic, which is display the characteristics polynomial of a matrix and hence find the eigenvalues. So what we know that uh, if lambda is the eigenvalue, then determinant of a minus lambda I will give the characteristics polynomial in terms of lambda, and its root will give the eigenvalues. So let us perform this operation. So x is equal to poly 0 comma colon x. So poly command is used to define x as a symbol rather than a variable. Now here x denotes the eigenvalue. So the constructor, we will represent the characteristics polynomial with p, and p will be equal to a det a minus lambda I. So here we are using x in place of lambda. So I will write x star I. I is an identity matrix, and it should have same size as that of a. Therefore I 3 comma 3. Okay. So this will give me the characteristics polynomial. Now let us display the characteristics polynomial. The characteristics polynomial of a is this p. Now let us see whether we getting something useful or not. As you can see, the characteristics polynomial of a is 18x plus 15x square minus x cube. So this is a very simple characteristics polynomial, and it will have 3 roots, and all the 3 roots will represent the eigenvalues of a. Since we are getting the determinant of a equal to 0, which is, and since determinant represents the product of eigenvalues, therefore at least one eigenvalue should be equal to 0 or approximately equal to 0. So let us calculate the eigenvalues which are the roots of the characteristics polynomial. So for eigenvalues of a are this e. So now let us again execute the code, and we can see one eigenvalue is equal to 0, as I have told, because determinant is equal to 0 or nearly equal to 0. Therefore that means one eigenvalue, at least one eigenvalue of the matrix A will be equal to 0, and we are getting the same. What we have done is we have displayed the characteristics polynomial of the matrix A and find the eigenvalues using that characteristics polynomial. Now the next topic is display eigenvalues and eigenvectors using inbuilt Scilab command. So what we will do is we will calculate the eigenvalues and eigenvectors using inbuilt Scilab command and compare the result with the one which we have obtained using characteristics polynomial. Okay. So I have written a comment here already. Now we will use v comma e, and so we will contain we will store the eigenvectors, and we will store the eigenvalues. So we will use the command spec a, and now we will display this double quotes the eigenvalues are this e, and similarly this double quotes the eigenvectors are this v. Okay, now let us display the output, and we can see the eigenvalues are 16, minus 1 and 0. Here also the eigenvalues are 16, minus 1 and minus 1 into 10 to the power minus 15. So this is also approximately equal to 0. So we can see that the values we have calculated are more accurate than this one. But we can say that if we want to write a big code and we do not have much time to calculate the characteristics polynomial and then eigenvalues, then spec is a beautiful command and which gives us the accurate, almost accurate answer. And the second thing is we have not calculated the eigenvectors, which is a tedious task to calculate manually, but the Scilab inbuilt command is giving the eigenvectors as a column of these matrices. So the eigenvector corresponding to the first eigenvalue 16.11 will be the first column containing the elements 0.23, 0.52 and 0.81, and the eigenvector corresponding to minus 1.11 will be the second L column, and the eigenvector corresponding to this third eigenvalue will be the third column. Okay, so spec, the beauty of this command is it gives us both eigenvalues as well as eigenvectors. On the other hand, using characteristics polynomial, we have obtained only the eigenvalues, and to calculate the eigenvectors also, we have to perform a lot of work. So these are only the few operations which I have covered in the Scilab. There are plenty of operations which we can do use with the help of the matrices in Scilab.